Good day, CRTians. Welcome again to our YouTube channel. For this video lecture, we will solve set 2 of our sample problems in physics/dynamics. So let's begin. So given the blocks of masses interconnected by a cord are pulled by constant force P equals 500 newtons. Assume frictionless surface. Find the acceleration and tension in the cord. So the tension in the cord is here. Okay, the tension between the blocks of masses, 5 kg and 10 kg mass. So first, let us consider the direction of motion. As you pull this block of masses using P, the movement is to the right. Therefore, the direction of the acceleration of the system is also to the right. So this is the direction of the acceleration. Let us now consider the free body diagram in each block. So for 5 kg, so let's say this is the 5 kg mass. Okay. Its free body diagram is first the direction of the tension. The direction of the weight is downward. But since this is frictionless, we will not use the value of its weight. Then we will be using the formula or the second law of Newton. So this is F net equals mass times the acceleration. With respect to this free body diagram, F net must be the force in the direction of the acceleration. So this is the direction of the acceleration. Therefore, all of the forces going to this direction is equivalent to the F net. So the only force going in the direction of the acceleration is the tension T. This is equivalent to the mass. The mass involved is 5 kilograms and A is the acceleration of the whole system. This is our equation 1. Next, considering 10 kilogram mass, its free body diagram is this. You have 10 kilograms. To the right of 10 kilogram mass is the force P. To the left is due to the tension in the cord, which is going to this direction. If you are going to apply the F net equals MA, again, F net is the net force along the direction of the acceleration. Same thing with 5 kilograms, the direction of the acceleration is going to the right. And all of the forces going to the right will be considered positive. And opposite to that is negative. So to represent F net, this is positive P and minus T equals the mass involved here is the 10 kilogram mass. And A is the acceleration of the system. So this is equation 2. Let us bring the solution up here. So from equation 1 and equation 2, we can substitute T. T is 5A from equation 1. We can substitute that to equation 2. Therefore, we have P minus T. This is equivalent to 5A, right? So let us replace T here using 5A from equation 1. This is equivalent still to 10A. So negative 5A, transpose that to the right side. We will leave P alone in the left side. Therefore, we have 10A plus 5A. Further simplification, P equals 15A. And to solve for the acceleration, this is P over 15. Our P is 500 newtons. And then over 15, this will give us an acceleration of 500 over 15 is 33.33 meters per second squared. So this is our answer for this first example. Okay, so you can take note of some shortcut if you are dealing with the system of blocks of masses. So we can use a certain shortcut in calculating the acceleration. And this is equivalent to F net divided by the summation of the masses, or the summation of mass. So how are you going to use this shortcut? In using the shortcut, you have to consider the whole system. You don't have to break down the free body diagram of the whole system. So therefore, A is equivalent simply to the available force, which is P, over the summation of masses, which is 5 and 10. Substitution, P is 500 newtons over 5 plus 10 is 15. This will give you still a 33.33 meter per second squared acceleration. So this is our solution, two possible solutions for this type of problem. Okay, that is our solution for the first requirement, the acceleration. Now, to solve for the tension in this example, okay, so to solve for the tension, you can either use the free body diagram of 5 kilogram mass or the free body diagram of the 10 kilogram mass. So meaning you can choose between equation 1, equation 2. So let us just use equation 1. So from equation 1, the tension is equivalent to 5 times the acceleration. So 5 times 33.33. Let us compute for that. And this will give us 166.65 newtons. And this is our answer for the required tension. Example number 2. Almost the same with the previous example, with the inclusion of the third block with 15 kilogram mass. The blocks of masses interconnected by cords are pulled by a constant force P equals 500 newtons. Assume frictionless surface, find the acceleration and tension in the cord. So for this setup, let us establish some concepts and parameters here. So again, first, take note the direction of the acceleration. The direction of the acceleration is going to this direction. So that is the direction of the acceleration. Next, since we involve 3 blocks of masses here, so we have tension 1 between 5 and 10 kilogram masses. And we have another tension. So this is tension 2 between 10 and 15 kilogram masses. And again, this is our assumption, frictionless surface. So we will not, consider, we will not use the effect of the weight for this problem. And also, we presented some shortcut from the previous slide or example. Our shortcut there is, let me change my ink. So for the shortcut, the acceleration of the whole system is equivalent to the F net divided by the summation of masses. So the F net, the available force in the drawing, in the whole drawing is only P. So we will no longer consider T1 and T2. T1 and T2 will be considered if you are going to use the free body diagram during analysis. So this is simply P over summation of masses, 5 plus 10 plus 15. Substitution, P is 500 newtons over 30 kilograms. And calculate that, 500 over 30. This is equivalent to 16.67 meter per second squared. So this is the acceleration of the whole system using our shortcut. But we are asked to solve also the tension or the tensions. We have two tensions here, T1 and T2. So we need to analyze its free body diagram. Consider first the 5 kilogram mass. So this is the 5 kilogram mass. The direction of the tension 1 is going in this direction. Applying F net equals mass times acceleration. For F net, the only available force is T1. So let me put the direction of acceleration here. Therefore, T1 is positive. Okay. M is 5 kilograms. A is 16.67. Solving for this, 5 times 16.67, this is equivalent to 83.35 newtons. Okay, so this is the direction or this is the tension between 5 and 10 kilogram masses. To solve for tension 2 or T2, let us isolate or draw the free body diagram for 10 kilogram mass. For 10 kilogram mass, the tension or T2 is going in this direction while T1 is in this direction. T1 due to the 5 kilogram mass. But still, don't forget that the direction of acceleration is to the right. Therefore, every force in our F net going to the right is positive. So again, using F net equals MA. F net here is T2 positive, T1 negative. Equals, mass here is 10 kilograms. A is acceleration of the system, 16.67. Therefore, so transpose T1 and solve for 10 times 1 or 10 times 16.67 is 166.7 plus T1. Our T1 is 83.35. Solving for T2. This will give us 250.05 newtons. So this is our T2 for this example. Example number 3. This is almost the same with example number 1, but this time we have to consider the friction. So the block of masses interconnected by a cord are pulled by constant force P equals 500 newtons. Assume the friction or the coefficient of kinetic friction equals 0.3. Find the acceleration and the tension in the cord. So if we have to consider the coefficient of friction, take note that we have to consider the weight. Let's say this is mass A and this is mass B. So the weight of mass A is going in this direction. And there is a normal force perpendicular to the contact between surface and the block. So this is the normal force A. So this is weight of block A. While for the 10 kilogram mass, this is the direction of the weight B. And this is the direction of the normal force B. So you have to take note for that. And still, the direction of the acceleration is going to the right. So let us solve. First, let us calculate the value of weight A. So what is the value of weight A? This is equivalent to the mass times the acceleration due to gravity. So this is 5 times, we will be using 9.8 meter per second squared for the G. And this is 49 newtons. While for WB, this is equivalent to 10 kilograms times 9.8. So this will give us 98 newtons. Next. So the direction of the movement is to the right. Therefore, the friction is opposite to the direction. With respect to mass A, there is a frictional force going in this direction represented by Fa. While with respect to mass B, there is a frictional force in this direction, Fb. So what is the formula of the frictional force? Frictional force is equivalent to the coefficient of friction times the normal force. For Fa, this is mu is 0.3, N is equivalent. So let us first solve the NA. Based from the free body diagram, NA is going upward while WA is going downward. Or simply, solve the summation of vertical forces. Okay, when you analyze the vertical forces, it will simply give us NA equals WA, while NB equals WB. Therefore, going back in the calculation of Fa, equivalent to 0.3 times NA is also 49 newtons. This is equivalent to 14.7 newtons. While for frictional force due to mass B, still you have to use mu n. So this is 0.3 times NB NB is WB, which is 98 newtons. This will give us 29.4 newtons. So we'll already have FA and FB. Let us now calculate the acceleration of the whole system. So the acceleration of the whole system is F net over summation of masses. So in this case, if you take a look at the whole drawing, the involvement or the force involved in the calculation of F net are the following: the force P, the frictional forces FA and FB. Okay? And since the direction of the acceleration is going to the right, P is positive, while FA is negative, and FB is also negative. All over summation of masses, 5 plus 10. Next is substitution. P is 500, FA is 14.7, and FB is 29.4. All over 15. So therefore, let us now calculate acceleration. This is equivalent to 500 minus 14.7 minus 29.4 all over 15. This is 30.39 meters per second squared. Next, let us calculate the tension. The tension is in between of 5 kilograms and 10 kilograms. So let us just use the free body diagram for 5 kilograms. There is a force, there is a tension in this direction, and there is a frictional force A in this direction. Using again the F net equals MA formula. F net here, take note, the direction of acceleration is to the right. Okay, so every force going to the right is positive. For this drawing, the only positive force is T, the tension. And the negative force for this drawing, for this free body diagram, is FA. This is equivalent to the mass involved, 5 kilograms, times the acceleration of the system, 30.39. So therefore, T equals, let us solve first, 5 times 30.39. And this is equivalent to 151.95. Transpose FA. So this is positive FA, while FA is already available and equivalent to 14.7. Solving for the process or the operation, we have 166.65 newtons. So this is our next example. 3 blocks of masses interconnected by cords are pulled by a constant force P equals 500 newtons. Assume the coefficient of kinetic friction is 0.3. Find the acceleration and tensions in the cord. Okay, so since the friction is involved, we have to represent or we have to consider the effect of the weight. Again, this is mass A, this is mass B, and this is mass C. The direction of the acceleration is to the right, while the direction of the frictional force, FA, FB, and FC are all going to the left. What else? The effect of the weight. This is the weight of A. This is the weight of B. This is the weight of C. And for the normal force, this is the direction of normal force A. This is NB. And this is NC. For this free body diagram or initial directions, we can say that the weight is equivalent to the normal force. So calculating weight A, this is 5 kilograms times the acceleration due to gravity, 9.8. This is 49 newtons. While weight B, this is 10 kilograms times 9.8, we have 98 newtons. And weight C, this is 15 times 9.8, this is equivalent to 147 newtons. And this is also the value of the normal forces, NA, NB, and C. Okay, so let us now calculate the frictional forces, which is equivalent to mu times the normal force. So for FA, this is 0.3 times 49 newtons, and this is equivalent to 14.7 newtons. While FB, this is 0.3 times 98 newtons, equivalent to 29.4 newtons. FC equals 0.3 times 147 newtons. This is equivalent to 44.1 newtons. So we can now solve for the acceleration of the whole system. This is F net divided by the summation of the masses. Again, direction of A is to the right. Therefore, F net is equivalent to P, positive P, because the direction of P is also to the right, minus the frictional forces, minus FA, minus FB, minus FC, all over summation of the masses, 5 plus 10 plus 15 kilograms. Substitution in the numerator, so we have P, 500 newtons, minus FA, 14.7, minus 29.4, and minus 44.1, all over 30 kilograms. So, solve the indicated operation. This will give you 13.73 meters per second squared. Next is to calculate tension 1. So for tension 1, so at mass A, so let us just present the solution in simple way. Let us just refer to the drawing. In tension 1, using the formula F net equals MA, F net is T1 minus FA. Right? The involved M is 5 kilograms and the acceleration is 13.73. So T1 equals 5 times 13.73 plus FA. Right? Transpose FA, it will become plus FA. FA is 14.7. Therefore, we can now solve T1. Okay, use your calculator. 83.35 newtons. So this is T1. Okay. Solving for T2, the tension 2, let us consider the 10 kilogram mass. So at MB, our F net there is T2 minus FB equals mass, which is 10 kilograms, times the acceleration, 13.73. By the way, we still need to include the effect of T1 with respect to 10 kilogram mass. So the effect of T1 there is minus T1. Okay, for the substitution, this is tension 2 equals 10 times 13.73 plus FB plus T1. So further substitution, this is 10 times 13.73 plus FB, this is 29.4 plus T1, this is 83.35. Solving for T2, this will give us 250.05 newtons. Okay. Thank you for watching this video lecture. If you think you learned something from this lecture, please subscribe to this channel. Click the like button, share this with your friends and classmates, and if you want, you can leave a comment in the comment section. Thank you and God bless to all.